Okay, so now the load shader. So let me see, the load shader. They're talking about this function, the load shader. The load shader function takes as input the WebGL context, the shader type, and the source code, then creates and compiles the shader as follows. So we have a new shader is created by calling the gl.create shader, and as you can see here, where is it? So we are inside of the so let me see, we are in the cons shader gl.create program. Okay, so we have a new shader is created by calling the gl.create shader. The shader source code is sent to the shader by calling the gl.shader source. Once the shader has the source code, it's compiled using the gl.compiler shader. To check to be sure that the shader successfully compiled, the shader parameter gl.compile_status is checked. To get its value, we call the gl.getShader parameter, specifying the shader and the name of the parameter we want to check. So we have the gl.compile_status. If that's false, we know the shader failed to compile, so show an alert with the log information obtained from the compiler using the gl.getShader and info log. So then delete the shader and return null to indicate a failure to load the shader. So as we can see here, we are getting the delete. So we have the gl.getShader info log, then we have the gl.delete shaders, and then we are returning null. So we have that. We have the create program. Okay, so that's fine. The fragment, let me see, no, maybe just like that. So let's keep moving. Okay, so now 5. If the shader was loaded and successfully compiled, the compiled shader is returned to the caller node. Add this code to your main function, and again we only have one JS file, so only this one. Okay, so we have let me see, we initialize this. So now we're gonna go outside of this function name, okay, init shader program, and let's just grab the comments and paste it. Okay, so now initialize a shader program. This is where all the lightning for the vertices and so forth is established. So let's have this let's add this piece of code. So we're gonna have this variable name, so it's gonna be a constant, but the name is gonna be shader program. Okay, shader program, like that. Okay, so it's gonna be the shader program, and we're gonna set it to, so it's gonna be set to init shader program, and the parameters are gonna be gl, and it's gonna be the vs source, and then it's gonna be the f source. So we have the gl, the vs source, and then the fs source, and then we ended up with a semicolon at the end. We save it with Ctrl S. So let's keep moving. After we've created a shader program, we need to look up the locations that WebGL assigned to our input. In this case, we have one attribute and two uniforms. Attributes receive values from buffers each time iteration of the vertex shader receives the next value from the buffer assigned to that attribute. Uniforms are similar to JavaScript global variables. They stay the same value for all iterations of a shader. Since the attribute and uniform locations are specific to a single shader program, we'll store them together to make them easy to pass around. So now we're gonna add this code to our main function. So again, we're in JavaScript, so I'm just gonna copy this comments and I'm gonna paste it. So it's gonna be here. So we're gonna collect all the info needed to use the shader program, look up which attribute our shader program is using for a vertex position, and look up uniform locations. So we're gonna go below and we're gonna start typing. Okay, so we're gonna have in this variable name program info. So let's, oops, not let, it's gonna be cons. What was the name? Program info. So it's gonna be program, and it's gonna be like this, camel notation, program info. We're gonna set it to something. We're gonna open curly braces, and inside of the curly braces we're gonna have in the program, we're gonna have colon here, program, shader program. So it's gonna be shader. Okay, like that, shader program. We are gonna separate it by a comma. We're gonna have attrib locations. So it's gonna be attrib, like this, attrib locations, colon, and we're gonna open curly braces, and we're gonna have the vertex position. It's gonna be vertex position, like that. It's gonna be vertex position. We're gonna have colon GL, and we're gonna put a get GL, get attribute location. So it's gonna be get attrib location, like that. So it's gonna be GL get, okay, attrib location. We're gonna open parentheses, and we're gonna have shader program. So it's gonna be shader program. Okay, and now as the second parameter, we're gonna have in this, okay, this string that is gonna be a vertex position. So it's gonna be a vertex position, like that. And then we're gonna end it with we're gonna separate this with a comma, like that. And okay, so we're closing with this curly braces here. We put a second a comma outside of the curly brace. And okay, so what else do we're gonna have the uniform location. So below here, so we have the program attribute locations, and now it's gonna be uniform locations. So we're gonna have the uniform locations, and again we're gonna open colon, we're gonna open curly braces, and inside of the curly braces we're gonna have the projection matrix. So it's gonna be projection matrix. So it's gonna be projection matrix, and again we're gonna open colon. It's gonna be GL that, and it's gonna be similar to this one. Instead of get attribute, it's gonna be get uniform location. So it's gonna be get uniform location, and again and camel notation. And we're gonna have in the shader program, and the style is gonna be the U projection matrix. So comma, we open double quotes, is gonna be U projection, and then it's gonna be matrix, like that, U projection matrix, and we save it. So U projection matrix. Okay, and we're gonna separate it with a comma here. Okay, U projection matrix. And what else do we have inside of this curly braces of the uniform location? We're gonna have the projection matrix, and also the model view matrix. So we have the projection matrix and the model view matrix. So we're gonna go here, and we're gonna have in it's gonna be model view matrix. Okay, so colon, and now we're gonna have the get uniform location. So it's gonna be the same, GL that is gonna be get uniform, get uniform location, get uniform location. Okay, so we're gonna have in the shader program, and now inside of the double quotes we're gonna have the U model view matrix. So it's gonna be U model, and then it's gonna be the view matrix, like this. So we can save it, and we're gonna separate it with a comma here. Okay, so we have we can put a comma at the end of this curly brace. So this curly braces up to here is just the uniform locations. Then we have this curly braces up to here is the attribute locations, and then we have the program. So we have up to this point, and we're gonna put a semicolon just at the end. See, we can save it, and this is the code that we just added. Now we are almost done, but creating the square plane. Before we can render our square plane, we need to create a buffer that contains its vertex positions and put the vertex positions in it. We will do that using a function called init buffers, which we will implement in a separate JavaScript module. As we explore more advanced WebGL concept, this module will be augmented to create more and more complex 3D objects. So we're gonna create, what it means is we're gonna create another JavaScript file. So we're gonna go here and we're gonna click this one, new file. Let me see. Create a new file called init buffers.js. So I'm just gonna grab this name and give it the following content. So I'm gonna click here and just gonna paste it, and I'm gonna have this init dash buffers.js. So now we're gonna have this code, so we need to type it in. Okay, so we're gonna have this function named init buffers. So we're gonna have a function, and we're gonna name it init buffers, like that, and inside of the parentheses we're passing in the GL. So we have init buffers, init buffers. We passing in the GL, and outside of that we open curly braces. Okay, so now we're gonna have in this variable name position buffer. So it's gonna be const, and it's gonna be position buffer position. Okay, it's gonna be position buffer, and we're gonna set it to something. So we're gonna set it to init. So we're gonna set it to init position buffer. So it's gonna be init position, okay, buffer, like this, and we're gonna open parentheses, and we're gonna pass in the GL, and outside of that we're gonna end it with a semicolon. Okay, so we have position position buffer, init position buffer GL. Okay, so we have that. Okay, now so we're gonna return, and we're gonna open curly braces, and we're gonna return position. So we're gonna return position, we're gonna return the position, and colon, and it's gonna be set to position buffer. So it's gonna be position buffer, like that. We're gonna separate it with a comma. Maybe in the future we're gonna have more. So okay, so let me see, we're gonna end this with a semicolon, this return, and this is set for this function init buffer, since we are closing it here with the curly braces. So this is set for this function. Let's move down, and now we're gonna have in this function init position buffer. So it's gonna have this function init position buffer, and inside of the parentheses we're gonna pass in the GL, and now we're gonna open curly braces, and we're gonna create. So let's just grab this comment, let's paste it, create a buffer for the squares position. So what do we have here? So we're gonna create this variable name position buffer. So it's gonna be position buffer. It's gonna be position buffer, and we're gonna set it to GL, and it's gonna be gl.create buffer, gl.create buffer, like this. We're gonna go here, put a semicolon at the end, position buffer gl.create buffer. Okay, and now we're gonna have this. I'm gonna copy just the comments, and we're gonna move here. Let me see, we are still here in the position, create. We're gonna move below, so I'm still inside of this. Let's move it. So now we have select the position buffer as the one to apply buffer, and select the position buffer as the one to apply buffer operations to from here out. So here we're gonna start typing some code. Let me see. We're gonna start typing here. So we're gonna have the GL that bind buffer. So we're gonna have in the GL that bind buffer like this. GL that bind buffer. Okay, so we're gonna open parentheses. We're gonna have in the GL, and it's gonna be that array, and then it's gonna be underscore buffer like that. We're gonna have a comma, and we're gonna have in position buffer. So position buffer, the second one. So we're gonna have in position buffer. We're gonna end it up with a semicolon here. Okay, so we're gonna have the GL that bind buffer, and we're passing us two arguments, GL that array underscore buffer and position buffer. So now let's grab just the comment, and now create an array of positions for the square. So let's do that. Let me see. We're gonna have this variable named positions, and let's just grab these ones, or no, let's just type it in. So it's gonna be cons, and we're gonna name it okay, we're gonna name it positions, and we're gonna set it to something. So we're gonna open brackets, and okay, so we're gonna set it to this array. It's gonna be 1.0 comma 1.0 comma 1.0. Let me see. This one, the third one, is gonna be negative, and then we're gonna have a comma, and okay, we're gonna have 1.0. We're gonna have again 1.0 separated, then it's gonna be a negative 1.0 comma negative 1.0 comma, and finally again another negative 1.0. So we can save it, and we have 8 values. So we're gonna have two are okay. Let me see. The first two are positive, the third one is negative, next two are positive, and the three last ones are negative. So we have that. Okay, so let's just grab this example. Let's move below. So let me see, let's move it to the right. Now pass the list of oppositions into the WebGL to build the shape. We do this by creating a float 32 array from the JavaScript array, then use it to fill the current buffer. So let's try it out. We're gonna go here, and we're gonna have in this GL that buffer data. So we're gonna have in this GL that buffer data in uppercase notations, and we're gonna pass in the buffer array. So it's gonna be GL that array buffer. So it's gonna be array underscore buffer like that. We're gonna separate with a comma. We're gonna have in new, and it's gonna be float, new float. Oops, it's gonna be float, and we have it here, float 32 array. And now we're gonna open parentheses, and we're gonna have in them then we're gonna have in them positions. Okay, let me see what else do we need here. Okay, so we have one argument, two, we need a third argument. So this is the second one. We need a comma here, and we're gonna have a third and final argument that is gonna be the GL that static underscore door. It's gonna be static underscore throw like this, and we can just save it. Okay, we're gonna end with a semicolon at the end. Control S to save it. So we have that, and we're gonna return position. We're gonna return position buffer. So we're gonna return position buffers. Oops, position buffer. We're gonna return the position buffer, end it with a semicolon, and okay, let me see. So we're gonna return with the position buffer, and outside of this curly braces we're gonna export it. So let me see. Okay, so we have this function. Let me see if it's right. So we have, let me see, the function is init. No, let me see, function init buffer. So let me see. Okay, so function init position buffer, and then we're gonna have the cons position buffer, init position buffer. So why is that? Init buffer, function init position buffer. Okay, function init position okay, so I have it here. Okay, so yeah, it's fine. Okay, so let me see, I'm gonna move here after this curly braces. Okay, so it's this curly braces is coming from the init position buffer, so it's coming from the init position buffer. So okay, so outside of this curly braces what we are gonna have is the export. So we're gonna export like this, and we're gonna export the init buffer. So in curly braces is gonna be init buffers, and we save it, and semicolon at the end, save it. Okay, so let me see. Okay, return position buffers, curly braces, export init buffers. Okay, that's fine. Okay, let's keep moving. This routine is pretty simplistic given the basic nature of the scene in this example. It starts by calling the GL objects create buffer method to obtain a buffer into which we will start the vertex positions. This is then bound to the context by calling the bind buffer method. So once that's done, we create a JavaScript array containing the position for each vertex of the square plane. This is then converted into an array of floats and passed into the GL objects buffer data method to establish the vertex positions for the object.